Hello everyone, I am Remy Jonkam Oben, a PhD candidate in the Department of Business Administration at Near East University. I present to you our research paper where we investigated both the symmetric and asymmetric impacts of financial development on environmental sustainability in Morocco. As we all know, climate change threatens global environmental sustainability. It is a major global concern nowadays. Morocco, a country in North Africa, faces significant environmental challenges. For instance, there are rising temperatures, that is global warming and extreme weather events. This is due to high carbon dioxide emissions and emissions of other greenhouse gases, particularly from the burning of fossil fuels for energy generation. Now, there are many determinants of carbon emissions or environmental sustainability. One of the potential determinants is financial development, because financial development can play a major role in mitigating climate change. Morocco, as a country, has a proactive approach to try to control climate change by transitioning from non-renewable energy sources to renewable energy sources. For instance, they have the North Solar Power Station. Now, the relationship between financial development and environmental sustainability in developing country contexts remains unclear. The literature has focused and given more attention to advanced countries, and in the context of developing nations like Morocco, the literature is relatively scarce. So, in this study, our primary research question is: to what extent does financial development help mitigate climate change in Morocco? Now, while investigating the impact of financial development on carbon dioxide emissions, we employed renewable energy consumption as a control variable. What are the gaps from the literature? As I mentioned before, limited attention has been given by researchers to developing countries in the sustainability finance literature, especially in Africa. Studies have focused more on the symmetric relationship between these variables, and less investigation has been done about the asymmetric connections. Therefore, this is the first study to employ both the Fourier ARODL and the nonlinear ARODL models in the sustainability finance literature by looking at both the symmetric and asymmetric relationships. No consensus has been arrived at in the literature. While some studies found a positive relationship between financial development and sustainability, others found a negative relationship. And theoretically, we look at the fact that there are different channels through which financial development can affect sustainability. Through economic growth channel, financial development can be detrimental to environmental sustainability by increasing carbon dioxide emissions. But through the channel of green finance, financial development can potentially reduce carbon dioxide emissions, thereby enhancing environmental sustainability. This study employs annual data from 1990 to 2019. Environmental sustainability is proxied by carbon dioxide emissions. Financial development is proxied by domestic credit to the private sector. And we have renewable energy consumption as a control variable. Since this is time series analysis, we start by conducting unit good tests to ascertain the orders of integration of the variables, and then we employ the Fourier ARODL model for the symmetric relationships and the nonlinear ARODL model to ascertain the asymmetric connections. The Fourier ARODL model is very efficient in capturing the relationships even in the presence of both smooth and sharp structural breaks. For the preliminary analysis, now we are looking at the descriptive statistics. We have 30 observations for each variable, and besides, we log transform these variables so we can reduce the potential of multicollinearity and heteroscedasticity and other problems that might be inherent in the data. We see that on average, financial development has the highest mean and the highest standard deviation compared to the other variables. All variables are negatively skewed. And looking at the Jagbera test, we notice that all variables are normally distributed, because the null hypothesis of the Jagbera test cannot be rejected since the probability values are all greater than 10%. In terms of correlation analysis, we notice that both financial development and renewable energy are highly correlated with the dependent variable, which is carbon dioxide emissions. Financial development is positively correlated with carbon dioxide emissions, while renewable energy is negatively correlated with carbon dioxide emissions. There is no hint of multicollinearity in this model because the correlation coefficient between the independent variables, that is financial development and renewable energy consumption, the correlation coefficient is just minus 0.7, which is less than 85%. So there is no hint of multicollinearity. Looking at the graphical plots, clearly we can see that there is a positive relationship between carbon dioxide emissions and financial development, whereas there is a negative relationship between carbon dioxide emissions and renewable energy consumption. For the unit root test, we employed the augmented decay Fuller, the Phillips-Perron, the KPSS, the Zivot-Andrews test, also the Fourier ADF test, and all tests showed us that generally all variables are integrated of order 1. That is, they are non-stationary at their level forms, and then they are stationary when we take the first differences. Now, for the symmetric relationship, we employed the Fourier ARUDM model. First, looking at co-integration, the Fourier ARUDM model showed us that the variables are co-integrated. That is, there is a long-run equilibrium relationship among the variables. In particular, with the F-bounds test, we notice here that the F statistic is greater than the upper bound critical value at 5% level of significance. Now, in terms of coefficients, the Fourier ARUDM model showed us that there is a positive relationship between financial development and carbon dioxide emissions, and a negative relationship between renewable energy consumption and carbon dioxide emissions in the long run. For the asymmetric relationships, again, the nonlinear ARUDM model co-integration results showed us that the variables are co-integrated, as the F statistic is greater than the upper bound critical value at 5% level of significance. And looking at the coefficient results for the nonlinear ARUDM model, it tells us that positive changes in financial development increase carbon dioxide emissions, while negative changes in financial development decrease carbon dioxide emissions. And we have similar pattern for the relationship between renewable energy consumption and carbon dioxide emissions. And to validate the inclusion of to validate the presence of asymmetric relationships, we perform the word test, and the F statistics are all statistically significant, which shows that there is asymmetric relationship between these variables, and it was necessary to perform the nonlinear ARUDM model. So, the key findings, to reiterate the key findings, financial development generally increases carbon dioxide emissions in Morocco, while renewable energy consumption decreases carbon dioxide emissions. And there are nonlinear relationships between these variables. Therefore, policymakers should prioritize infrastructure development for clean energy. They should channel financial resources towards sustainable projects. They should improve access to sustainable financial services, and they should develop financial sector with environmental considerations. So those were the main results of our study. Thank you so much.